So a couple key things to point out are that this is not a diamond, that this is considered a rhombus. So make sure that you note that, okay? I also put some other information at the top over here that says AB is congruent to BC is congruent to CD is congruent to DA, all right in here. That's what that first bit of information tells you. This second bit of information here, you got two slopes the same, AB is parallel to DC. Same thing over here, two slopes are parallel, or two slopes are the same, they're parallel. These are not negative reciprocals, okay? They're not flipped, they're just negative. So that's why they're not making right angles here. They're not supposed to. A rhombus doesn't have all right angles, all the same. The other thing to note is when you go downward, diagonal length. Diagonal length is 4, and the other diagonal length is 6. And that really doesn't tell us anything. Diagonal slope, one is undefined and one is 0. So that tells us that those diagonals are hitting at 90-degree angles. If you want to go back up here and put the diagonals in, you'll see this one's going to be going horizontal, that one's going vertical. You might want to even put a little 90-degree angle right in here for that picture. Again, the midpoints are the exact same thing for the diagonal, so that does show us something as well. So some things that are old, you got two sides that are parallel because they have the same slope. The midpoints are the same on the diagonal, so they bisect each other. But that's pretty much all the old stuff. Those are the properties from the parallelogram, from its daddy, the parallelogram. Now we've got two other things. All sides have the same distance. That is special of a rhombus. You might be saying, well, it's also something of a square. Squares have all sides the same distance. Yes, but think about the chart that we did. Squares is a descendant of the rhombus. So a rhombus, a special rhombus, is considered a square. So it's both. Some of them are both rhombus and square. It's possible to be just a rhombus like this. This does not have 90-degree angles in it, but it's for every square, it's also a rhombus. It fits all the criteria for rhombus. When we look up here, we've got all sides have the same distance, they're congruent, and the diagonals are negative reciprocal slopes. So the diagonals are perpendicular, and that is special of all rhombus, and it will pass on to the square as well, that these diagonals hit at 90-degree angles. So I put a little note down here. Rhombus must be proved with distance alone or in addition to other formulas. We can't just do negative reciprocal slopes for diagonals and say it's a rhombus, because when we do the kite, those also typically have perpendicular diagonals. So you have to be talking more about, and that's why you can't tell, but this is kind of highlighted here. All sides have the same distance. If you know that, you know it's a rhombus. It might be a special rhombus, might be a square, but it's definitely a rhombus. So take a minute and flip this page over and try to prove it's a rhombus, and keep in mind, we're sticking with distance. That will prove you don't have to do all the other stuff. It's just distance, because if it's got 4 equal sides, it's definitely a rhombus.